Good day, folks. Here's another question. It's a 2017 Gauteng province. It was a September exam. Let's cut the chase. A diagram below shows an electron transition between energy levels of an atom. If you look at the energy diagram here, it's the higher energy level to the lower energy level. So the energy level increases as you go up. There's an energy increase, and it is an energy decrease as you go down. So now if you look at the electrons, the electron A, it's moving from energy level 4 to energy level 1, B energy level 3 to energy level 1, C energy level 4 to 2, and so forth. And each level has its own energy, right? Now this type of energy, this line, it's an emission line spectra or spectrum, right? Where there's an energy, what is happening to the energy of the electrons as they move from the higher energy level to the lower energy level? There's an energy released. The energy is given off in terms of light. The energy is given off in terms of light. Now let's answer the question in 10.1. It says a photon of light is released when an electron moves from energy level 3 state to the energy level 1 state. Calculate the frequency. So we are referring to this one, from energy level 3 state to the energy level 1 state. Energy level 3 has that energy, and that has that energy. So we are answering this question here, 10.1. It says calculate the frequency of the photon. So this frequency gives off the energy, and that means there's a frequency for that energy. So the way we're gonna do that, we're gonna use the formula. We have to calculate the change in energy. There's an energy change from that to that. We need to calculate that energy, which is that energy that is released. So it's energy level 3 minus energy level 1, which is going to be negative 5,44 times 10 to the power negative 9 minus, and this energy, which is open bracket, negative 2,18 times 10 to the power negative 18, and then the answer will be 6 point, no, the answer for that, when we calculate that, it will be, let me punch it, it's gonna be negative 5,44 times 10 to the power negative 19 minus 2,18 exponent negative 18. The answer it's 1, did I calculate it right? Yep, it's negative 1,636 times 10 to the power negative 18. That's the energy that is released. It's joules. So now, in order to calculate the frequency of that, we're going to use the formula that says E is equal to frequency, Planck's times frequency. So we wanted the frequency for that, so we substitute the energy there. So it's going to be 1,636 times 10 to the power negative 18 minus, we're not minusing, we're substituting here, and then the Planck's constant is going to be 6.63 times 10 to the power negative 34 times the frequency. And then the answer that we have here, we're going to divide by this. So the answer, divide by 6, which is the Planck's constant, and the negative 34. So the answer is going to be 2,447 times 10 to the power 15 hertz. That's the frequency. That's the frequency that we have there. And then 10.2, how many different photons can be produced when excited electrons move from energy level 3 to 1. From 3 to 1, it's going to be 1, 2, 3. It's going to be 3. So the answer, it will be 3 there. And 10.3.1, it says define the work function of a metal. Work function of a metal is the minimum energy in the metal required by the metal to emit the electrons from a surface of the metal. Guys, exam guideline when it comes to that. The last question, 10.1.3, it says the photon in 10.1 is incidented on the metal. Now it says the work function, we're given the work function there. With the work function of the metal, it says calculate the maximum velocity for that. Guys, we're going to use the formula that says the energy of the photon is the sum of the work function plus the maximum kinetic energy. So what are we going to do there? What are we going to do? The energy, we do have the energy of the photon, so we're going to substitute that. We do have the work function, so we're going to just, okay, let's substitute the energy. The energy, it's 1.63 1,633 times 10 to the power negative 18, and the work function we're given there, it's 2 times 10 to the power negative 19, plus the kinetic energy we are not given, we wanted the velocity. We have the mass is 9.11 times 10 to the power negative 31, and the velocity is the one that we want. So guys, when we take that to that side and then we divide by that, when we put the square root there, the answer is going to be 1,78 times 10 to the power 6 meter per second, which is, that's the velocity of, or the speed of the ejected electrons. I hope this question makes sense, guys. Cheers, bye.